JSON, or JavaScript Object Notation, is the preferred data format for exchanging data between mobile apps and hosted services on the web. Oracle's Java Development Kit doesn't have a standardized library for working with JSON, but the Android SDK includes an implementation of a package named org.json that's defined by an open-source standards body. You can find information about this package in the Android documentation. From the API Docs homepage, I'll search for org.json. And that takes me to the documentation for the package. There are 4 classes and 1 exception. The 2 classes that you'll use most frequently are JSON Array and JSON Object. Both have tools to extract child objects, also defined as either arrays or objects, or at the lowest level as primitive or simple values, numbers, strings, booleans, and so on. To demonstrate this, I'll work with this project named read.json. Here's what I'm starting with. I have an assets folder that contains a file called data.json. When I double-click to open it in Android Studio, I see just the first line, but I'll go to the menu and choose View, Active Editor, Use Soft Wraps, and now I can see all of the file's contents. The first character of the file is a bracket. That means I'm starting with an array. And then within that array, there are multiple objects, each wrapped in braces. Each object has a number of values. Each value is a key value pair, and the key is first, and then after a colon is the value. Strings are wrapped in quotes, and numeric values don't have quotes around them. And that's about all there is to know about this JSON file. So now my job is to read the file from the assets folder and then parse it, looping through the objects and displaying some information about each item that the file represents. In this version of my application, I've taken some code that I created in another video to read a file from the assets folder, and I've extracted it to its own class. I've named that class FileHelper, and the code is in the new method readFileFromAssets. This method receives the current context and a file name as a string. Then it reads the file, and if everything is successful, it returns the string that the file contains on line 24. If any exceptions happen, it logs those exceptions to the logcat window. And in the finally block, it closes the reader. So now this file can be used whenever you need to read a file from assets. In my main activity class, when the user clicks the Run button, I'm using that new static method, I'm reading the file, and I'm displaying its contents in my text view that I've named mlog in my JSON code. So let's see how the app works in this beginning state. I'll touch Run Code, and I instantly read the file from disk and display its contents. So now my next job is to extract the files using JSON parsing. I'll start here in the method onRunButtonClick. I'll maximize the editor window, and I'll create an instance of the class JSONArray. I'll name it JSONArray, and I'll set it with a constructor method that accepts a string. Notice that there are a number of different constructors here. Because I already have a JSON string, I can just pass it in. Now, when I complete the line of code, I see an error indicator, so I'll use an intention action, and I see that this code could throw an exception. So I'll surround this line of code with a try-catch block. And then I'll start adding more code here within the try section. So now I have an array, and I'd like to find out how many items there are in it. I'll use my displayMessage method, and I'll output there are, and then I'll append to that JSONArray.length. And I'll finish the message with items. And I'll run the code again. And I see the message there are 34 items. If I scroll down to the bottom of the screen, I see that message displayed at the end of the contents of the file. Now I want to loop through that array. The JSONArray class does not include the tools you would need to use iterators or Java's newer for each syntax, so we have to use a standard for loop. I'll start with the for keyword, and I'll declare a counter variable that I'll name I and set to 0. Then I'll keep looping as long as I is less than the length of the array, and I'll increment the value by 1 on each time through the loop. Within the loop, I'll start by creating an instance of the JSON object class. This will be used to represent each item in the array. I'll name it item, and I'll get its value by calling JSON array.get, and I'll pass in a value of I. I see an error indicator, so I'll use an intention action, and I'll cast the result to JSON object. Next, I'll extract two values. I'll go back to my data file to remind myself of the names of the values I'm looking for. I'm going to be extracting the price and the name. The price is a numeric value that I'll cast as a double, and the name is a string. I'll create a variable named itemName, and I'll get its value by calling item.getString, and I'll pass in a key of name. Then I'll declare a primitive variable typed as a double that I'll name itemPrice, and I'll get its value by calling item.getDouble, and I'll pass in price. The JSON object class has methods for strings, doubles, integers, and all of Java's other simple data types. Now I have two values, and I'll put them together into a string that I can display. I'll create a string builder object that I'll name builder, and I'll instantiate it with new string builder, and I'll start by passing in the item name. Now I won't complete the statement here because now I'm going to chain a number of calls to the append method. I'll call append, and I'll pass in a literal string of space, open parenthesis. Then I'll call append again, and this time I'll be passing in the double value of item price. Then I'll append again, and I'll pass in a closing parenthesis and a \n for a line feed. So now I have a string that I can display, and I'm going to call mlog.append, and I'll pass in that string with builder.toString. I'll make one more change. Now that I'm displaying some minimally formatted values, I no longer need to display the raw contents of the file, so I'll comment out that line of code on line 35 that was displaying all of that text. And I'll run the app again. And I'll run the code, and there's my result. I'm successfully parsing the JSON file and extracting the names and prices of each item. So this is an example of an instance where the Android SDK does something that Oracle's Java Development Kit doesn't do. The JDK doesn't include a standardized package for working with JSON content, but the Android SDK does, by implementing an open source package, carefully following its specifications, and including it as part of the core Android SDK.